Hey everyone! Ever look at a math logic problem and just your brain feels like a pretzel? Yeah, we've all been there. Well, you're in the right place, because in the next few minutes we're going to straighten all that out. I'm going to give you a super simple framework that'll have you walking into your exam feeling totally confident. Ready? Let's jump in.
So here's the game plan. First, we got to nail down the absolute basics. What is a statement in logic? Once we've got that, we'll get into the fun stuff, the 5 key tools you'll be using. Then we'll learn the rules of the game with truth tables, see how it all works with some real exam questions, and, most importantly, I'll show you the common mistakes so you don't make them. Let's kick things off with that first step.
All right, first things first. Before we can start connecting any ideas, we have to know what a solid logical idea even is. Seriously, this is the foundation for everything that comes next, so let's make sure we get this right. So let me ask you a simple question. Is every sentence you say a logical statement? Like if you ask, "What's up?" or tell someone, "Hey, pass the remote." Do those count? Well, in normal life, maybe, but in the world of mathematical logic, the answer is a hard no. Let's get into why. And this is the golden rule right here. A logical statement is basically like a light switch. It's either on, which means it's true, or it's off, meaning it's false. There's no in between, no kind of true. So for a sentence to count, it has to do 2 things. 1, it has to declare something, like a fact. And 2, you have to be able to look at it and say, without a doubt, yep, that's true, or nope, that's false.
Okay, check this out. On the left, you've got real statements. The moon revolves around the earth. That's true, right? Now look at the next one. 6 times 4 equals 25. Obviously, that's wrong. But, and this is super important, it is a statement, because we can definitely say it's false. See how that works? Now look at the right side. What is your name? Open the window. You can't say true or false to those, so they're not statements. Simple as that.
Okay, now here's the first big trap people fall into. It's called an open sentence. Take a look at x plus 6 equals 9. Is that true or false? Well, it kind of depends, doesn't it? If x is 3, it's true. But if x is anything else, it's false. Since its truth value can change depending on the variable, it's not a statement. Remember that, because it's a classic trick question.
Okay, so we know what a statement is. Awesome. Now let's get our hands on the tools we use to connect them and build bigger ideas. Think of this like your mathematical logic toolkit. And here they are, the 5 essential connectives. You've got and, or, if then, if and only if, and not. Each one has a specific job, helping us connect or tweak our statements to say more complex things. Honestly, if you can master these 5, you've pretty much mastered this whole topic. So let's dive into the rules for each one.
So, how do we know how these tools work? Well, that's what truth tables are for. And listen, don't just try to memorize these tables. That's the boring way. Think of them as the instruction manual for each tool. It tells you exactly what happens in every single situation.
First up, we have conjunction, or just and. This one is super strict. I want you to think of it like needing 2 keys to open a treasure chest. Both keys have to work. For an and statement to be true, both parts have to be true. Look at the table. The only time we get a T at the end is when we start with T and T. Any hint of a false, and the whole thing becomes false.
Next up is disjunction, or. Now this one is way more chilled out than and. For an or statement to be true, you just need one of the parts to be true. That's it. So if you have a true and a false, it's still true. If you have 2 trues, of course it's true. The only, and I mean the only way for or to be false is if both parts are false. That's the one you got to remember.
Okay, everybody, deep breath. This is the one that trips everyone up, the conditional, or if-then. But here's an easy way to think about it. It's a promise. Let's say I promise you, if this video gets 1,000 likes, then I'll make another one. Now think about it. When is the only time I've broken my promise? It's if the video does get 1,000 likes, that's true, but I don't make another video, that's false. A true leading to a false. That is the only scenario where this is false. Every other time, the promise holds.
All right, moving on to the biconditional. This is if and only if. The keyword here is sameness. It's like an equal sign for truth values. This is only true if both sides match. So true and true, they match, that's true. But what about false and false? They match too, so that's also true. The only time this is false is when the values are different, like 1 true and 1 false.
And finally, we've got the easiest one of them all, negation, or not. This is literally just a flip switch. Whatever the truth value is, not just flips it to the opposite. So not true becomes false. not false becomes true. That's it. Super easy.
So, we've got the fundamentals and we've got our toolkit. Now it's time to put it all together. Let's tackle some problems just like the ones you're going to see on your exam.
Okay, let's get our hands dirty. Here's a classic problem, turning a sentence into symbols. The sentence is, Delhi is in India, but Dhaka is not in Sri Lanka. The first step is always to hunt for the connecting words. I see a but, and I see a not. What tools from our toolkit do you think those are?
Let's break it down step by step. First, we define P as our first simple statement. Delhi is in India. Easy. Step 2, we define Q. Dhaka is in Sri Lanka. Now for the translation part. That word but, it logically just means and. And not in Sri Lanka is, well, the negation of Q. So we put it all together and we get our final answer, P and not Q.
All right, you ready to level up? This time, we're not just finding symbols, we have to find the final truth value. Check out the sentence. The key phrase to lock onto here is if and only if. So for this, it's a two-step process. First, let's figure out the truth value of each part. Milk is white? Yep, that's true. The sun rises in the west? No, that's false. So what we really have is true if and only if false. Now we just remember our rule for the biconditional. Do the truth values match? Nope. T and F are different, so our final answer has to be false. Okay, this next part is huge. Let's talk about the common traps, the places where students lose marks. If you know what to look for, you won't fall for them. This is going to save you a lot of trouble, I promise.
So here are the top 3 mistakes I see all the time. Number 1, getting fooled by an open sentence with an X in it. We talked about that. Don't let it happen. Number 2, forgetting that questions, commands, exclamations, they are not statements. Just cross them out. And number 3, this is the biggest one, mixing up the conditional rule. Let's say it again. If then is only false when a true leads to a false. That's it. Seriously, tattoo that one on your brain.
All right, let's wrap this up with a quick recap. What did we learn? A statement has to declare something and be clearly true or false. Your 5 tools are and, or, if then, if and only if, and not. The truth tables are your non-negotiable rulebook, and your game plan is always the same. Identify the statements, turn them into symbols, and then just apply the rules. You can totally do this. So we've covered the rules that will help you crush your exam, but I want to leave you with something bigger. This stuff, it's not just for math class. It's literally the code for clear thinking. It's how computers run, how lawyers win cases, and how we all can make smarter decisions. So the real takeaway isn't just solving for P and Q. It's asking yourself, how can you use these tools to build a better argument, to think more clearly? Think about it. Thanks for hanging out, and good luck with everything.